Again, thank you everyone for joining this session on the scope storage. I'll move directly to the content of this hour together. The content will be mainly divided into three parts. The first one is an informative session about the scope storage, deriving mainly from the Android documentation, which is publicly available. Second part, a little shorter, hands-on, just a few exercises that I've done for you in order to really understand the impact of the scope storage while developing and writing some code. And the final part about the Secure Storage Manager, which is a tool designed by Zebra to support you developers to deal with the scope storage and make your life easier when it comes to face the new challenge introduced by the scope storage. We'll try to keep a few minutes at the end of the hour for a Q&A, and so for now, let's move on. A quick reminder, I've also shared a handout for your convenience containing all the links I've used in this presentation. And by the way, my name is Nicola De Zolt. I'm a software engineer at Zebra. I'm mainly focused on the developer experience on Zebra mobile computers, and I'm based in Milan, Italy. So let's move to the informative session, which I called a top-down approach to the scope storage, because we start just looking at what's happening from a documentation point of view. I'd like to start recalling what are the locations for storing data in an Android device. And we have the internal storage and the external one. Both of these storage types are used for persist files and cache data. But the internal storage is used for access just by the applications, and starting from Android 10 and higher, all the internal storage are also encrypted. The external storage, on the converse, is used to share data and store data in a way that it can be shared with other applications. So the documentation specifically is telling us that when an application wants to share a file, this file should be placed in a shareable part of the external storage, so in precise folders built for this purpose. As I was saying, a device has always one and only one primary storage volume, but it could be also have extra volumes like removable SD cards, USB drives, and so on. So the external storage is rather complex, and the scope storage limitation is intended to limit up access to the external storage. In Android 11 and higher, all these limitations cannot be skipped in any way, compared to Android 10 when the scope storage was introduced and the user could opt out of it in a specific way. But above that API level, that's no more possible. I'd like to elaborate a bit deeper on the scope storage. Just taking a look at the types, that are typically used when building a device. So we have a traditional external storage that can encompass both the emulated and the portable storage. With emulated storage, we mean a type of storage that is external but is exposed as a portion of the internal. So typically it's encrypted, and its path is beginning with the /storage, /emulated, and so on. The number 0 after that usually means it's a primary. traditional storage. The portable storage instead is defined as anything else that is not adopted, which we'll see immediately next. And this type of storage typically offers less protection for data. SD cards and USB fall under this type of storage, and their typical path is /storage/ some number defining, for instance, the SD card and so on. In the example that I pasted in the right side of this slide, I have listed what's happening in TC21 devices when I'm looking at the storage types, and you see that there are 3 types. The emulated SD card that was inserted, and the self-storage, which points to the primary external storage. I was saying another type is the adoptable external storage, which is encrypted and formatted to behave like an internal one, despite it's been mounted externally. There are some SD, which, for instance, the /SD card path can be migrated to an adopted external storage, and this way all the applications and data will be installed in this adopted external storage. Again, the scope storage applies to all of these types of storage. And so, yes, the removable SD cards and the USB volume are subject to the scope storage, and there are specific APIs that you want to use when you need to detect which is the path of the primary and the secondary storage available for your application. You use the get external storage directory API to return the primary shared external storage. When dealing with multiple external storage, instead directory, you want to get the list of directory, you can use the get external file dirs or cache dirs or media dirs and the storage volume class. In the next slide, I have a couple of examples of how these have been used in the code. Android, from the best practices that you can find on the Android documentation, if you're still targeting the API 29 or lower, you can declare the right external file storage, which is no more useful for API levels above those. Otherwise, you can use the media store or direct file access. We'll see how. The Zebra devices have always been featured with an enterprise folder, which is used to persist files across our enterprise reset. So where the an enterprise reset happens when you reset everything in the device except this folder, which is called the /enterprise path. In Android 13, and this is to confirm that in Android 13, the /enterprise /usr path will still be writable for third-party apps. So it's the behavior exactly the same as in Android 11. For the next major version of Android 14, instead, this will be discontinued, so a third-party app won't be able to write to that folder by default. So be aware that you should rely with caution on this path with the writing permission. I said this is an example of how the get external files tiers and the get external storage return on the device I was using as an exercise with an SD card mounted. So with the first API, I got 2 entries, the /storage /emulated, and the storage with the SD card ID in the path with its data folder. For the get external storage directory, instead, this is pointing to the first volume of the emulated storage. So you might wonder why the scope storage has been introduced. The main reason for that is about privacy, is to protect privacy of app and user data. And apps and user data translate into protecting user information, such as pictures and videos and audio files, preventing app from modifying or deleting other files without an explicit permission, or protecting documents downloaded by an application into a specific folder. However, sometimes the actual behavior is slightly different than what the documentation prescribes, and so appreciate the difference between the goal and the actual behavior. That's why in the second part of this presentation, I did some exercise with some code that I've shared on GitHub, just for you to understand what is exactly the real behavior of application in presence of the scope storage. Another point is that Android appears to be a consumer-centric OS, which means it's been designed with the personal use in mind. So our use cases that are generally of interest for Zebra customers are not at the top of the mind for the designers of Android. Some enterprise concerns have been captured recently by the Android Enterprise Framework, but these are mainly about EMMs and how a device is managed by a device owner and so on. The use cases that I'm listing here are not yet completely addressed by the new version, a major version of Android, and so we still have to find a way to cope with them. Such use cases for the enterprise include what I've listed here, for instance, site loading a configuration file for a business application, something that in our environment is really a must, but also the converse, exporting and sharing data from an app's log, for instance. And you probably want also that the log, which can include some sensitive information, is also protected, but can be read from third-party apps. Other use cases in the enterprise which are involved in the file system include, for instance, a business app that is used to take pictures, and these pictures are later moved or consumed by another application or shared on an SD card. A business application consuming huge binary data. This is the case, for instance, when machine learning trained models are to be loaded into a device, and cases like similar to these. All such cases are deeply impacted by the scope storage, and so you need a special care to address them. I've arranged, extracted this word cloud from the official documentation of Android on the scope storage. At the center, with bigger font, you see the real nature and what is about the scope storage for Android designer. It's all about the media store and the media files. You can also find other interesting keywords like the versions of Android, the best practices, and the permissions. But the main interest is about the media files. And in the end, most of the work is done around these type of files. So analyzing the documentation, I found that these four main dimensions have emerged and need to be addressed when you want to deal with the scope storage and you want to design your application to work well with it. These dimensions are the types of shareable data. So what kind of data are you going to share? And the permission that you need to manage and to grant and ask the user eventually. Then there's a theme around the distribution of the app, and this is strictly connected to the target API level that you're setting to your application. And finally, how the another application is consuming the data that first one has shared. Let's move into these dimensions just to understand the impact and what are the main concerns that you should understand and see while designing your application. So the end perspective of sharing data inside a shareable storage is also helped by the fact that Android provides a set of APIs for each type of data that you want to share. And the media content is the first one that has been supported by the Media Store API, which provide a way to deal with the all type of media files, so pictures, videos, and music and audio files. This set of API is very specific to this kind of file. And for instance, for the pictures, you have an API that can return the ISO number of a picture, so something that is really typical of just that type of data. The direct file access is still supported, but just for compatibility reason. The mainstream, the most suggested and important way to manage these type of files is through the Media Store API. The documents and other files are intended like PDF, EPUB, or other types like those, so well-known types of files. In this case, the official documentation is suggesting using the storage access framework, which is interesting, but is not usually an option in the enterprise because a dialogue asking the user interaction, how to manage a file, choosing a directory, and so on, is not an option in our use cases, because the workers that have our devices in their hands are not supposed to choose and work with the location when they want to save a picture they have just taken. The data sets is another type of well-known data that can be shared, and there's with dataset we mean those big database of file database full of binary data that have a specific a set of API called the Blob Store Manager. Through this API, the system is able to share this big data across several users with the specific use case like the machine learning or media playback. For handling non-media files, instead, there's a specific guide from Google. The address here is embedded here, but is available in the handout that I've shared. Is an interesting reading because it's covering some of our the use cases that I've listed before. So, for instance, writing to a secondary volume, migrating files from a legacy storage location that will be anymore valid for the coming Android version, share the content with our apps, and caching non-media files and exporting non-media files to a device. The guide is very detailed, and so I invite you to have a look at that and adapt your application accordingly. Another dimension that I've found interesting is about the permissions. The first thing you should be aware is that permissions are changing with every major version of Android, and as Daniel said in the past session, for Android 13, the read media images, read media video, and read media audio have been introduced so that a developer can ask exactly the permission needed to manage the single type of file without using broader permission as it happened in the past. To access the location which is embedded into pictures, for instance, there's a specific new permission to the data and the access media location, and the manage media instead has been introduced to make life easier for developers and managing media content without asking the user consent, which is, I think, a great thing and moves toward the needs that we have in the enterprise. If you think you have enough from the scope storage and you're trying to get rid of it somehow, well, Android offers a way to skip it entirely, and this is the manage external storage permission. It's called the all file access, and it really works well, but of course, it has some side effects. The first of it is you need to ask the user to expressly accept the storage permission. So the user is advised on the fact that they're granting the permission to access any files on the file system. There's also a way with our Stage Now configuration tool, as depicted in the right side of this slide, to grant this permission in a silent way. You need, however, to know the application signature, which is the targeting this permission. However, despite it looks a good way to skip it, we'll see in the coming slide that this permission has also some important side effects, and so you should be very cautious in using it. To draw a conclusion on the permissions, let's see how the scope storage is really behaving from Android 11 and on. First of all, the write external storage and write media storage permission have no special privilege anymore. That's because in presence of the scope storage, all the writing permission have been defined by the operating system. And so you don't need any more asking them and declaring them to the user. The read and write access to the own files of an application happens without any permission. So reading other application media files requires the read external storage permissions, and writing access to for the media files to other application is allowed only with the direct user consent. No read and write access to others application of external data application is allowed. And as said before, the manage external storage permission plays a big role since you have full access to any files in the file system. In this picture, all the main cases of private storage on the left and shared storage on the right are listed, and they show when you need to ask to declare a permission to operate with that specific branch. So in the private storage, the left branch, for any read or write case, you have no permission to declare or to ask the user. For the shared storage instead, you said what I've said so far. You need the read storage permission to deal with other applications. You need the storage access framework if you want to deal with non-media read mode, and again when you want to write non-media files for other applications. Moving on to the app distributions and dealing with the target APIs. So here the Google Play comes in, and the very important thing is that you're planning to distribute your application through the Play Store. You really need to apply the rules for complying with the target API level. For instance, if you want your app to be discoverable for new user, your application needs to target at most the two previous major version. Today we are in with API 33 with Android 13. You need to target API 30 or 31 and 32 in order to be discoverable for new users that want to install your application. Otherwise, your application won't be listed. For the update requirements instead, you have only 1 year to adapt your application, and so this time is even shorter in case of the update requirement. You can see in the upper right side of the slide that today the latest version, the API level 31, is required for new apps, and both for new apps and for updating an app. As of today, December 2022, the next level will be August 2023 and November 2023, when the API level 33 will be necessary to post application to the Play Store. And of course, adopting the target API of that levels make you fall fully into the scope storage requirements. But there are also additional requirements to push an application to the Play Store. First of all, to be a good citizen of the Play Store, you need to apply all the permission and APIs and the rules that are listed here in this at this link. And first of all, you need to be to request permission that are really necessary for your application, nothing more, nothing less. And for the managed external storage, the intended use is only that is reserved for those apps that really need to manage files on behalf of someone else. And for instance, this is a case of file managers, antiviruses applications, and so on. And every application that declares the managed external storage and want to be published on the Play Store needs to pass a special review by Google and declare the intent of the application, and is closely monitored. That's why using this permission is usually not an option for many developers. Again, still on constraint on the target API, if you want to lower the target API level, just trying to skip the scope storage, well, this is again not an option, because going down the levels, for instance, on Android 13, if your application is targeting below API 26, every time you install your application, a pop-up, a blocking pop-up, is warning the user that the application is targeting something old, and the application is declared as an old version of Android that needs to be updated. For Android 11, this API level falls below the 23. Not even StageNow can help here, so you really need to comply with the current directions and upgrade your target level, not to have this pop-up showing up when the application is installed. Finally, there's also a requirement and constraint about using application targeting all API level, for instance, an API level 27 or lower, at that level, you were still able to share and make your data directory word readable. But what happens if you're trying to leverage this fact when your application targets Android 11 or above? It will be prevented accessing those data directory, even if the application shared it in the beginning. Final dimension to address when dealing with the scope storage is about consuming data. So how are two or more apps exchanging and reading this data and consuming that? First of all, keep in mind that you should share just what is needed. So use the internal storage as much as possible, and just use the external storage for sharing data. And stick to the media rules if you are dealing with those kind of files, and for the non-media rules, non-media files and data, understand how we implemented and how our devices are working. And this is the topic of the second part of this presentation. And understand the subtle differences in different versions of Android. That's really important to come to a good application design when you have to deal with the file system. In general, migrating to Android 13 requires you to understand the behavior of the changes that apply to all apps when running on Android 13. That is the case that I've shown a few slides ago. Also check the behavior that only affects application targeting Android 13, and understand the main dimension of the scope storage as explained so far. There's no one size fits all, meaning that the approach cannot be decided unless analyzing exactly what the need of your application. In general, refer for the migration to the link that I'm showing here, which lists the main steps you have to take to comply with the Android 13 requirements. As said, let's move to a bottom-up approach. So keeping an eye on what's happening when you trying to write to a specific folder on the Zebra devices. For your convenience, I've picked 7 locations on the disk, which are mainly the SD card, the /SD card personal, which is a folder created externally through ADB. The typical SD card download folder, the same folder but through a different path, which is available on the Android devices, documents folder, and the data folder of the application I was testing, and finally the enterprise one. I tried to write from an application to these folders a simple text file in the form of an XML or plain text files. And for instance, I found that there's an operation not permitting writing into the root of a SD card, and even in a folder that I've called personal, but was created through a different user. Instead, I was able to write into download documents, the application data, and the enterprise partition. All this was done with the manage external storage flag off, because of course, column number 2, if I switch on the manage external storage, I'm able to write on any folder that I've listed here. It's interesting to see what's happening in column 3 when I try to overwrite the files that were written with flag with the manage external storage on, putting it again in off position. In this way, I found that I have an access denied on these files on most of the folders, except the data folder of the application and the enterprise partition. This is the column 3 is something that might happen if you shared your application through a site loading and using the managed external storage initially, and they wanted, for instance, to distribute it through the Play Store. At that point, you have to switch off the flag, but you find that most of your location that you use with the flag on are no more accessible. A final note that I put at the top of this slide: note that starting with Android 11, through the USB, you are no more able to access the /enterprise partition that was previously available with lower Android version. Same behavior. These tests were used with the 6490 platform, which is the chipset of the TC58 and 53, for instance. The same result apply for the SD660 platform, which I tested through an MC3300X. Similar concept when it comes to reading the files written previously. If I read with the manage external storage off the files that were written with that flag off, there's no problem. Where the files were created, they can also be read. Of course, if files were written with the flag manage external storage on, and they are read with that flag on, everything can be read with no issue. Again, an issue happens if you try to read the manage external storage on files of files that were read then with that flag on. You can only access them when they are in the data directory of the application and the enterprise folder. It's interesting to see what's happened when a different app, so a different package name, is accessing the files that were written by another application, both with the manage external storage off. The only directory that is accessible is the application data file and the enterprise folder. Of course, with the manage external storage on, where the file is in place, there's no problem in reading it. I also tried what's happening when you want to read files pushed via ADB or USB, and this is what's happening is that you mainly have to work with the Android data folder, otherwise there's no access to files push, for instance, in the download. The application is not able to access it. For platform based on the SD660 chipset, I found that most of the cases are the same, except for the behavior of reading from a different app, where the Android data, in the case shown here, is not available. Comparing what's happening in writing between Android 11 and 13, the only difference is about reading with manage external storage flag and writing with the manage external storage flag off files that are written with that flag on. In this case, if you remember what I said about writing the 11, which is on the left side of this slide, with Ender 13, I had access to an earlier version of Ender 13. They are all overwritable, and so you can write to any of these locations. Comparing the reading between the Android 11 and Android 13 instead leads to a similar result. So with Android 13, you are able to read the same location that you wrote with all the manage external storage flag off as the same way as before. But again, the difference is about reading the folders that were written with manage external storage on and are read with that flag off instead. Across different apps, you get permission denied if you try to read files from the folders that you can see here and that were written with the manage external storage off. So the only folder that are allowed to be read with no problems are the data folder of the application and the enterprise one. Same things for the files pushed through an ADB or a USB. So the takeaway from this session is for sure having an understanding of what is the complexity when you have to deal with the scope storage. In the last slide, we have seen a lot of cases that arise from different Android version, the presence of the managed external storage, and so on. For a developer, we appreciate that probably it's very hard to manage all these cases and maintain an application. And so this is one of the reasons why the Secure Storage Manager has been introduced. The Secure Storage Manager is a service that is embedded into our operating system and has been placed there for securely sharing files and data. These are the two main cases, file and data, from an originating app to one or more target applications. Of course, an application can share data for itself for later use and use it as a pure storage, but an application can also share data to other applications. The Secure Storage Manager has been designed and is maintained by Zebra. So you have just one single interface and a very simple API to use this tool. And this is so you don't need to care anymore about the specific Android version or chipset version that you are addressing with your application. So for several use cases, this can be a valid alternative to the raw file system usage. In the very latest version of the Secure Storage Manager, a secure feature has been added, so you can even enter the data pre-encrypted. Say that you want to save or share a password. You don't want to input it into the Secure Storage Manager in a clear way. So you have now a tool which is called the data encryption tool. The address is in the handout, which allows you to encrypt the information in a way that once stored in the SSM, it can be retrieved and is automatically unencrypted when you later want to read it. So it provides an end-to-end data encryption of information. I said there are two use cases for SSM, sharing data means that you a first application, that is the originating one, is going to store data in a secure way, and the second application then will later retrieve it. The originating app at the moment of storing the application to the SSM can decide even to persist that data, and if so, the application, the data is saved through the enterprise partition in a way that is persisted across our enterprise assets. Besides, the target application is notified of new data available through observers, and there's just a limitation of how of the dimension data that can be stored, and this is at 10 kilobytes for each single record. For your curiosity, SSM, the Secure Storage Manager, is implemented as a content provider, so implementing the best in class object for storing data in a secure way. The APIs offer the so-called CRUD data actions, so create, read, update, and delete, like for any database. And the data is structured as a key value pair, and so you have to define this pair when it comes to call the API. We'll see in the next picture, in the next slide, an example of that. And one thing is about the ownership of data. The originating app transitioned the ownership to the target application, and once the data is delivered to the SSM, the originating app loses control of what was shared. This is an example of coding. You have to declare in your manifest some permissions to use in the read and write mode the Secure Storage Manager, and in the queries tag also declare the authority. The authority is also a string that you have to hard code into your application. If you need to retrieve the signature of a target application, we have made available a tool at this address, and the APIs are these 4 calls, namely the insert, the update, the query, and the delete. The insert works exactly as for any database on a table with a primary key, and so when you try to insert twice the same primary key, you get a violation exception. And instead, when you query the Secure Storage Manager, it returns a cursor, which is a typical structure for dealing with records and database, and then you have the delete API. Again, some code snippets. The first line is how a signature looks like. So it's a readable string that can be embedded in a file or in the code. Then you have to put it in a special key value pair before passing this to the Secure Storage Manager. You populate the key, which is called data name, the value, which is called data value. You specify if the value is encrypted or not, and if you want it persisted or not, and if the sharing is meant to be consumed by other applications or just for your own consumption. The observers are of 2 types. These are typical from content observers. One is the content observer, which is triggered when the data is changing. Instead, dataset observer is called when the cursor has a change in its life cycle. For instance, when the cursor is released at the end of a query, you get a call to this method on invalidating, for instance. Sharing files is the other use case of the secure storage manager. This is useful if you want to share or persist files above the 10 kilobytes, and the simple data sharing is no more an option. In this case, there's a quick recipe for doing that. You get the app signature of the target application. You deploy the file by calling the insert API. There's the target API. The target application is notified that a file is available, and it can then consume the deployed files. Everything is listed on our tech docs, and the links are in the handout. Here is the list of the API for the files, and I can just say that the insert in this case is not triggering an exception. If you insert twice the same file, you overwrite basically the previous one. And for the delete, when I wanted to delete as a target application, I wanted to delete a file that was shared to the target application, I had to overwrite it firstly, in order to take ownership of the file and then call the delete. In this way, it was successfully deleted. About the performance, SSM, of course, has not the same performance as the file system. As you can see in this, by columns, you have a number of records that are inserted into the SSM, and try the same with the file system. If you insert 100 records at one time, it takes just a couple of seconds, so perfectly in line with any expectation. If you try to insert 1,000 records, you have to wait with the SSM around 20 seconds with the device that was using, while the file system operates in less than a fraction of a second. But of course, if you want to use the file system, you have to deal with all the limitations of the scope storage, while the SSM offers a simple, unique interface, much easier to deal with from a developer's perspective. So we can see that the SSM has some pros and cons, but of course it's a great tool in the hands of the developer. I'm trying to save a few minutes. We're at the end of this session. Rolling back, we have just seen the SSM. Before, we have seen a session, the bottom-up reading of the effect of the scope storage, seeing how reading and writings in the different operating system version and chipset version are impacting the developer. And in the beginning, we have seen the top-down approach to the scope storage as it is defined accordingly to the official documentation from Android. We have seen some best practices and the 4 main dimensions to address when you are designing your application and want to comply with the new rules of the scope storage. Here is some links, but most of them are in the handout included in this presentation. And I'm over now. I thank you so much for your attention. We have 4 minutes, just only 4 minutes for some questions. So I'm asking James or Priyanka, is anything we should address?
Thank you there are a few questions. Thank you very much, Nicholas. So I'll just cover off a few of the housekeeping questions. So a couple of questions about the presentations being made available later. So We won't be sharing the presentations for download unless that's specifically requested. We could look into that, but they will be shared via YouTube in the next week or so after this session. So you'll be able to watch a recording of the session. And please let us know if you'd like a copy of the presentation. You can email us at developer@zebra.com. So we have 2 technical questions. The first one here for you, please, Nicola. What is the best practice to push a data wedge configuration file?
So for that, we have a specific session later. There are tools that specifically will address that. I'd say what you have seen so far is more to deal with your own files and deal with the application, not the Zebra ones. We have specific tools to address this issue and this concern for our tools like Data Wedge.
Yeah, perfect. Yeah, so as Nicola mentions, we have a session dedicated to that later on in the day, so do make sure to tune into that.
Yeah, exactly.
The other question then that we have here is from Ryan Grimm. So does the manage external storage permission allow us to bypass scope storage restrictions, or is that for something else?
It does. When you declare that permission and the user applies the consent, so the user is presented with a dialog box which is blocking, and if the user decides to accept it, yes, your application from that moment on is able to navigate almost everywhere in the file system, but with all the limitations that are presented before. So you cannot upload your application to the Play Store unless you really have a reason to do that. And yeah, doing that, you're somehow putting the privacy of the user data in a position that is not following the best practice of Android. That is the rest.
Perfect. All right, perfect. Thank you, Nicola. That's actually all the questions we have for this session. So we're going to move straight into the Rindu's session. So I'm going to bring this to a close, and please make your way over to the next session. So thank you very much, Nicola, for your presentation.
You're welcome. Thank you.